Alright, so what we're going to look at here is called the colligative properties of solutions. This is Unit 7, Lesson number 8. And first thing we're going to look at is boiling point elevation, but let's discuss what colligative properties of solutions, what that is. You're never really going to see that phrase, colligative properties of solutions. It's basically what happens to the properties of a solvent like water when you dissolve a solute to it. Specifically, we're looking at what does it do to the boiling point and the freezing point. And that depends on the concentration of the solute. In other words, how much solute is in the solution. So the greater the concentration of the solute, the greater the change that is going to be. And there's two things that will happen. It will raise the boiling point above 100 degrees Celsius, because that's the normal boiling point of water, or it will lower the freezing point to below 0, because 0 is the normal freezing point of water, which means it would be a negative value. And the more you add to the water, the higher the boiling point is going to go, and the lower the freezing point is going to go. And this is all related to, for example, why we use salt on the roads in the winter, and why you use antifreeze in your car, especially in the summer, so that it doesn't overheat. Well, let's take a look at first what an electrolyte is. And an electrolyte is definitely one of the top 15 or 20 definitions. Electrolytes are substances that conduct electricity when dissolved in water, and there are three substances that are electrolytes. Salts are one, of course. Salts, which means anything that is ionic. Second would be excuse me, acids, which we have not discussed yet. And third would be substances that are bases. I'll give you an example of each. An example of a base would be NaOH, sodium hydroxide. Example of an acid would be HCl. And a salt would be, of course, NaCl would be an example of a salt. All three of those conduct electricity. And the reason for that is that when you put them in water, they split apart into ions. And it's the ions, these free-moving ions, that allow the solution to conduct electricity. And if you see here, you can see that when you put calcium chloride in water, notice that it breaks up not into just calcium and chlorine, but it breaks up into one calcium ion and three chlorine or chloride ions. Now, why is that important? Well, it's important that you understand that when this breaks down, it breaks down into three total ions, right? One calcium and two chlorine. So it breaks down into three ions. That's extremely important. And you'll see why in a few minutes. When you put non-electrolytes in water, and a couple of examples of non-electrolytes, or actually I should say the best example of a non-electrolyte would be sugars. Sugars are non-electrolytes because when you put them in water, they do not split into ions. They stay intact. So they do have an effect on the boiling point and freezing point, but not as much as ionic compounds, which is also going to become important. Okay? Well, let's take a look at first boiling point elevation. And the animation is not very good. It'll take a little bit too long, so I'm not even going to worry about that. But boiling point elevation is the higher the concentration of a solution, the higher the boiling point of the solution is going to be. Again, the more solutes dissolved, the higher the boiling point is going to be. And remember, the boiling point is always then going to be above 100. And this at the bottom is not very good, but it's, and I'm actually just going to ignore it. It's just showing you the amount of salt in 2 cups of water, and then the boiling point. But this is in Fahrenheit, so it's kind of a waste. I should get rid of it. The more ionic particles in a solution, the higher the boiling point. We know that. So let's take a look at this. Remember, it's all based on the number of particles. So ionic compounds are always going to have more of an effect than covalently bonded compounds. So if you take a look, it says, which of the following solutions will boil at the highest temperature? Now, they all look very similar to each other, and they are. And it's not to fool you, it's just to make sure that you understand what's going on. So you have to figure out which one has the most solute in it per solvent. So this has 1,000 grams of water, and it has 100 grams of NaCl. Okay, this has 100 grams of NaCl, but in 500 grams of water. So already this one is more concentrated than that one, so that one we can cross out. This one has 100 grams of NaCl and 250 grams of water. Well, that's already more concentrated than this one. This one has 100 grams of sodium chloride in only 125 grams of water. So the one that's most concentrated is D. That would have the highest boiling point because it's the most concentrated. Now, they're not going to ask you exactly what the boiling point will be. You just need to be able to determine which one of the choices would have the highest boiling point. Okay, and there is the answer is D right there. Another one. Now, this is a little bit different. Still on boiling point elevation. It says, which solution has the highest boiling point? Well, if you take a look at it, what you have to determine is which ones are ionic or which ones are covalent. So this is ionic. This is covalent. It's a sugar. So right away you can just cross this one out because it's never going to be the answer. Again, this is ionic and this is ionic. So what you have to figure out is which one breaks up into the most ions. So if you put one KNO3 in there, it's going to break up into a K and an NO3. It only forms 2 ions. This breaks up into KNO3, but it's not 1 mole, it's 2 moles. So you're going to have 2 Ks and 2 NO3s. That comes out to 4 ions. So by far right now, that's the highest concentration, so I can cross this one out. Let's look at this one. This one's going to break up into a calcium and 2 NO3s. Well, that adds up to only 3 ions. So this one is the most concentrated right there. So that will have the highest boiling point. And that is